Okay, once again, back to recording. So, you need to choose the way you're going to scan the grid, because you've got to consider every single cell. If you miss a cell and it's got a 0 in it, you don't solve the problem. Okay, so again, I would choose a simple way to scan the grid. But if you want to do some cool diagonal and then over one, diagonal over one thing, fantastic. Just make sure you get every cell. The next question I had, it works now, that's weird. A bunch of people come to me saying, this is my recursive method. And I'm going to loop over all the cells. I'm going to do the scanning in the recursive method. So what could be wrong with that? You have a question or an answer?
An answer.
Okay.
It's going from 0 to 9, so that's 10.
No, less than 9.
Less than 9. Okay, never mind.
Well, the issue is that every time I call this method, what happens to I and j? They get set back to 0. So I'm scanning that 0, 0 cell a bazillion times. Right? Because the first time I call fill cell with a value of I and j, the row and column are set, but I go into my for loop and I start at 0, 0 again. And I keep going. So I'm rescanning that a ton of time. I'm wasting my time by looking at stuff I've already done. So we don't have to put the scanning inside the individual recursive call. We don't have to scan everything. We only have to scan one thing, one cell. Does that make sense? We can do the looping through the activation records. Yes?
Do you actually go over why it's scanning that one cell over and over again?
Well, because, okay, so I call fill Sudoku with whatever value of I and j I have.
Right.
What happens when I get into that method?
Starts at 0, 0.
Goes to 0, 1, and then I do some logic that says these are all filled. I keep going, I find the next empty cell. But I'm checking 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8. Oh, 1, 0, da, da, da. I keep checking that. I make a call. What do I start at? Where does the loop start?
Oh, this method is recursive.
Yes, this is the recursive method. So every time you recurse, you're going to start at 0, 0,
right.
Scan, recurse, start at 0, 0, scan.
Okay.
Why are you scanning all this jump that you've already bypassed?
I didn't realize this was the recursive.
Yeah, this is the recursive, because I got the row and actually, well, it doesn't matter. So this will work eventually. You'll just hit the 0, 0 cell 81 times 81? Some crazy number, right? You're doing a lot of work that you don't need to do. So this, I'm just going to give you pseudocode, is a simple way to recursively solve the problem. So the solve Sudoku method calls fill cell 0, 0 to start this whole joyous thing off. And the first thing we do is we check to see if we're at the end of our scan. I've checked all 81 cells. If I'm there, all I need to do is call the check Sudoku method that returns true if it's a success or false if it's a failure. Because if I've filled in every single cell, I can return that value. If I'm not at the end, and the cell is not a 0, meaning there's a value in it, what do? I don't need to do anything. I just continue on my merry way by continuing the scan to go and look at the next cell, whatever that might be, and then I call fill cell on that next cell. So this is where I recurse. So this is in the case where I see a 1 or a 6 or whatever, I just go to the next cell that I need to consider and do the recursion. if the cell is empty, meaning it's a 0, I need to go find all the valid choices for this cell. And that's that legal values method you got to write. So once I have the list of all the valid values for this cell, I loop over them. I set the cell's value to whatever that particular choice is, and then I continue my scan. So I continue the scan, I check the return value of if fill cell, because if it's true, I found the solution, and I return it. Return true. If it's false, I can't return false because I have some other choices I could choose. So if it had a solution, else we go back to the loop, choose the next possible value, fill cell again, until we run out of choices, in which case I need to set the cell's value back to 0, because somewhere along the recursion chain, we made a bad choice, and we could not solve this puzzle with the choices we made. So we reset the cell back to 0. That's the backtracking. So we want to keep this thing, refresh it back to 0. And then we return false, saying that this particular set of choices didn't work. Now, how many activation records will this have when I get to the end of the scan in the stack? I didn't. Well, yeah, I have 1 for every cell, right? So there'll be 81 calls in the thing when I finally get down to the end.
But those get popped off the stack, don't
They will, but again, it will be, because I'm calling it recursively, starting at 0, 0, I'm recursively calling for every cell. So I'm going to, at the end, I will have 81 in the stack. And then if it succeeds, I return true.
they? So before the return.
Before the return, you're going to have it, because you're not at the end of the scan. You can't say, oh, I've only tried 3 values and I'm done. I've got to get to the end of the scan. I have to make sure that I've filled out into all the zeros. And that's why, again, in some people's code that have shown me some problems, if you call check Sudoku and you haven't filled all the zeros, it will happily return true. You don't have a solution if you have zeros in your grid. So you end up with 81 activations on the stack, even for bad solutions. Then they all get popped back off, and then you go build up 81 activations again until you find the solution. That's not bad. It's just that's a lot of work you don't really need to do. So what you could do is only call fill cell when the cell is empty. So you do a scan, and if the value is non-zero, don't do the recursion, because you don't have to do anything. Just keep scanning. Just keep going until you find a cell, an empty cell, and then call the thing. Now that does change our logic inside of here, because we now know that this cell is empty, so we find the valid values, we look through the valid values. We do have to check to see whether or not we're done, as in we filled in the last empty cell. If we filled in the last empty cell, then we can call check Sudoku to see whether or not that choice worked. If we get through our loop, we go back, we reset to 0. I think that's it. Any questions?